Faster than the very structure of spacetime itself has the ability to keep it aware and act as a result, it will slowly deconstruct this idea, filling me with a sense of unease. Right now, our night sky is moving quickly, changing, and within the coming decades, maybe even sooner, it could become completely unrecognizable. Experts, including Neil deGrasse Tyson, are raising the alarm and recognizing changes that must happen due to the shifting background of Polaris. The reason behind this change is surprisingly unexpected. Polaris, commonly known as the North Star, has served as an enduring symbol in the sky for ages, acting as an essential point of reference for astronomers and navigators. However, this stability might soon be disrupted, altering the way we perceive the heavens and study the universe. Let's examine what this transformation might entail for us. Polaris has been a guiding light for sailors and astronomers for a long time, remaining securely elevated in the sky. Its steady presence has been essential for travel, but this stability may soon change. A paper from the highly regarded Royal Astronomical Society, published in September 2023, raised concerns about Polaris's future. The celestial marker is about to enter a tumultuous phase, one in which it could possibly explode and vanish from sight forever, changing our sky as we see it. Before considering the possible outcomes of this event, let's take a deeper look at the characteristics of the star itself. Polaris is distinctive due to its proximity to the celestial North Pole. Positioned directly above Earth's northernmost point, it appears almost motionless in the sky. It resides in the Ursa Minor constellation, commonly known as the Little Dipper. Polaris shines with moderate brightness, resembling a yellow-white colossal star significantly larger and brighter than our own Sun. However, Polaris is more than just a single star. It is part of a complex triple-star system consisting of Polaris A and Polaris B, which form a binary pair, with a third star orbiting them. Their respective gravitational forces influence their movements and behaviors, and any changes in their interactions could impact their brightness or pulsation patterns. However, the specific nature of these forces remains poorly understood. Polaris is situated about 3,223 light-years from Earth. This means the light we currently observe from it began its journey long ago. If Polaris had already exploded, we would not yet see the results. It's possible that Polaris has already undergone a catastrophic event, but we have yet to witness it. Throughout history, the North Star has held substantial cultural, navigational, and symbolic significance. Its constant position has made it an invaluable guide for ancient sailors navigating across seas and lands. Symbolically, Polaris has represented steadfastness and direction, remaining constant in the ever-changing night sky. For astronomers, it has been a crucial reference point in the study of variable stars and stellar motions. Its periodic brightness variations have provided crucial insights into stellar properties and the behavior of variable stars. Recently, however, Polaris has begun to exhibit signs of deviating from its usual behavior. This deviation from its normal pulsation cycle has intrigued astronomers, prompting further examination. Instead of adhering to its typical pattern, Polaris has started displaying erratic dimming, raising concerns that the star might be nearing the end of its life cycle. This behavior aligns with what is commonly observed in stars approaching their final stages. The gradual lengthening of Polaris's pulsation time, once steady, has been traced back to interactions within its star system. There has been a yearly increase in its pulsation period of about 4.5 seconds. While this may seem minor, it carries significant implications. Some astronomers hypothesize that gravitational forces within Polaris's system could be driving these changes in its atmospheric conditions, directly impacting its pulsation patterns. Others are more concerned that Polaris is entering a critical phase that may result in a supernova explosion. The similarities between Polaris and Betelgeuse, another significant star in the Orion constellation, are striking. Both stars have exhibited complex variations in brightness, suggesting they may be approaching a massive explosion. Stars nearing the end of their life cycles often display such irregularities before their final collapse. While NASA has expressed concern over Betelgeuse, formal attention has yet to shift fully toward Polaris. As a variable star nears the end of its life, it undergoes several stages, including the red giant phase, before ultimately culminating in a supernova explosion. Due to the erratic pulsations observed in Polaris, scientists speculate that it has entered the helium exhaustion phase, which is common for giant stars nearing their end. These irregularities align with patterns seen in other stars on the brink of collapse. However, definitive evidence of an impending supernova remains uncertain, and astronomers continue to monitor these anomalies to better understand Polaris's fate. Should Polaris undergo a supernova explosion, it would likely be a monumental event in the sky, potentially surpassing the brightness of the moon and remaining visible for days, weeks, or even months. Its brilliance could drastically alter our view of key celestial landmarks. If Polaris were to explode in a supernova, the effects would not only be visually stunning but also scientifically profound. The explosion would release an enormous amount of energy, possibly outshining every other star in the night sky for a period of time. Such an event would provide astronomers with a rare opportunity to study the death of a star up close, improving our understanding of stellar evolution and supernova mechanics. A Polaris supernova could also have effects on Earth's space environment. The explosion would release a powerful burst of radiation, including X-rays and gamma rays. However, because of its distance, over 3,200 light-years away, scientists believe it is unlikely to pose any direct threat to life on Earth. Still, the event could affect satellite communications and potentially influence Earth's upper atmosphere. Beyond the physical consequences, the loss of Polaris would be deeply symbolic. For centuries, it has served as a guiding light for travelers, explorers, and astronomers alike. Its disappearance would fundamentally change our perception of the night sky. Many cultures and traditions that have long associated Polaris with constancy and direction would need to adapt to a world where the North Star is no longer a fixed point. In the event of its destruction, a new North Star would eventually take its place due to the slow precession of Earth's axis. Over thousands of years, different stars occupy this position in the sky. In approximately 12,000 years, Vega, a bright star in the Lyra constellation, will become the new guiding star for Earth's northern hemisphere. However, no immediate replacement would exist if Polaris were to disappear suddenly. As scientists continue to observe Polaris, they are gathering data on its pulsations and brightness fluctuations to determine whether a supernova is imminent or if the star will persist for thousands of years to come. Advanced telescopes and space observatories are tracking its changes, looking for signs of instability that could indicate a nearing collapse. For now, Polaris remains a steadfast presence in the night sky, but its future is uncertain. Whether it continues to shine for generations or disappears in a cosmic spectacle, one thing is clear: our understanding of the universe is constantly evolving, and the stars we rely on today may not always be there tomorrow. Would you like me to expand on any specific aspect, such as the scientific process of a supernova or the cultural significance of Polaris? Constellations that look like the Ursa Major or Big Dipper, in which Polaris plays a crucial role, are fascinating. Fortunately, it would probably remain safe on Earth, regardless of whether Polaris explodes due to its size and distance from us. While the explosion of Polaris might not be as visually stunning as Betelgeuse's, it could still be visible for a prolonged period, outshining nearby stars. This would undoubtedly draw the attention of astronomers and observatories, generating widespread enthusiasm within the academic community and among stargazers. However, the impact on Earth's environment or ecosystems would not be as significant as that of a supernova occurring closer to our planet. But what will happen to Polaris itself? What is its fate after a potential supernova explosion? First, it's important to note that while massive stars typically end their lives in a supernova explosion, this outcome is unlikely for Polaris. When a large star undergoes a supernova, its core collapses, creating a powerful shockwave that causes the star to break apart. However, Polaris is not massive enough to undergo such a violent event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition will not lead to a supernova but rather a more subdued conclusion. As Polaris develops into a small, incredibly dense stellar remnant, it will become a white dwarf, the compressed core of a low to medium mass star that has exhausted all nuclear fuel in its nucleus. This remnant, although roughly the size of Earth, will still have the mass of the Sun. Once this process is complete, we will no longer observe Polaris as we know it. By comparing the potential explosion of Polaris with actual supernova events, we can gain valuable insights into the evolution of stars and their final fates. For example, supernova events like SN 1987A, SN 2011FA, and SN 2014J have provided critical data that help us understand what could happen to Polaris in the future. SN 1054, for instance, led to the formation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various frequencies, providing astronomers with a rich field of study. Additionally, SN 1987A, observed in the Large Magellanic Cloud, offered essential insights into nucleosynthesis, nebula mechanics, and the release of high-energy radiation. These discoveries may help us better understand the unique characteristics of Polaris. The formation of nebulae like the Crab Nebula occurs when supernova material interacts with the surrounding environment, enriching interstellar gas with heavy elements and contributing to the ongoing cycle of star formation and death. The release of high-energy particles and shockwaves from supernovae also has significant implications for astrophysical processes and cosmic radiation. To make a definitive comparison, researchers study differences in the production and speed of ejected materials between Polaris's potential explosion and other observed supernova events. By examining light curves, spectra, and remnants, they can make predictions about Polaris's fate. Research into the possibility of Polaris's explosion will help determine whether it could lead to nebula formation or significant variations in stellar distributions. Another important area of study is the pulsational variability of stars nearing the end of their life cycles. By comparing Polaris with other supernova progenitors, astronomers hope to gain a deeper understanding of the mechanisms underlying stellar explosions. The wide range of pulsations in dying stars may indicate internal instability or an impending catastrophic event, offering critical clues about the processes that lead to supernova explosions. Despite detailed observations, experts remain puzzled by irregularities in Polaris's behavior. Understanding the reasons for these anomalies is crucial for advancing our knowledge of stellar evolution. Investigating the factors contributing to Polaris's erratic pulsations requires collaboration across multiple scientific fields and the development of cutting-edge observational techniques and models. The potential disappearance of Polaris as a celestial reference raises fundamental concerns for astronomical research. Ground-based telescopes and celestial distance measurements would require adjustments, affecting the accuracy of cosmic calculations. The loss of Polaris would also impact navigation systems and cultural practices that rely on celestial markers, emphasizing the significance of this event. The mysterious behavior of Polaris highlights the need for further studies and focused research. Astronomers must address the complexities surrounding its erratic pulsations and provide meaningful answers to determine the star's future. The future of Polaris and its role in astronomy. As Polaris continues to evolve, astronomers remain focused on studying its behavior to refine models of stellar life cycles. The star's variability and brightness changes provide crucial insights into the physics of Cepheid variables, stars used as cosmic distance markers. Polaris, as one of the nearest and most well-studied Cepheids, plays a key role in calibrating cosmic distances, helping astronomers determine the scale of the universe. Any major transformation in Polaris's state would require recalibrating these measurements, potentially affecting our understanding of galactic and extragalactic distances. Additionally, Polaris's potential transition to a white dwarf offers an opportunity to study stellar remnants. White dwarfs serve as cosmic laboratories, allowing scientists to analyze degenerate matter, cooling rates, and the long-term evolution of low to medium-mass stars. While a white dwarf lacks the dramatic energy release of a supernova, its gradual cooling process still contributes valuable information about the thermodynamics of dying stars. Polaris in human culture and navigation. Beyond its scientific importance, Polaris has been an essential navigational and cultural reference point for centuries. Its nearly fixed position in the northern sky has made it a critical tool for explorers, sailors, and astronomers throughout history. The potential dimming or disappearance of Polaris over thousands of years would gradually alter how future generations perceive celestial navigation. Ancient civilizations, from the seafarers of the Pacific to medieval European navigators, relied on Polaris for orientation. In modern times, while GPS technology has largely replaced celestial navigation, Polaris remains a symbolic and practical reference in many fields, including military navigation and amateur stargazing. The broader cosmic context. The study of Polaris ties into broader questions about stellar evolution, the fate of stars in our galaxy, and the mechanics of stellar variability. Similar stars undergoing evolutionary changes provide comparative data that help refine our predictions about Polaris's future. By monitoring other Cepheid variables at different stages of their life cycles, scientists can better understand how mass, composition, and external factors influence stellar aging. Furthermore, advances in space-based telescopes, such as the James Webb Space Telescope and future observational missions, will allow for more precise monitoring of Polaris's spectral changes, pulsation periods, and surrounding environment. This data could help resolve lingering questions about its core structure, mass loss, and eventual transformation. Final thoughts. Polaris has long been a guide for both explorers and astronomers, serving as a beacon in the night sky and a key to unlocking the secrets of stellar evolution. While its eventual transformation into a white dwarf may take thousands or even millions of years, continued research on its behavior remains essential. The mysteries surrounding its pulsations, potential changes, and long-term fate underscore the need for ongoing observation and theoretical modeling. As technology advances and new discoveries emerge, our understanding of Polaris will continue to evolve, ensuring that this iconic star remains a subject of fascination and study for generations to come.